So we can also find an inverse algebraically if we're given an equation or a function initially. We're going to focus more on that in another lesson. Today I really just want to focus on switching our domain and ranges, understanding the graph of the inverse and the original. But when we're finding them algebraically, it's sort of four steps, not steps. The first one, if it's in function notation, just replace that f of x or g of x or whatever it might be with y. So like a number 2, f of x, that's really just y. So that's your first step. So replace that function notation with y. You want y equals. So an inverse is x and y switched. So that's step 2. Literally just switch x and y within your function, within your equation. But then when you do that, you guys have x equals whatever. And we never have x equals. Our functions, our equations, whenever we graph, it's always y equals. So once you've done that switching, because that's what an inverse is, the x and y switched, you need to then rearrange your equation and solve it for y, or isolate for the y value. So solve for your y, get y equals, and then you just write it in inverse notation. So we're going to write a step 4 in here. So inverse notation is that little negative 1 power. So like if you initially had f of x, writing f to the negative 1 of x notes that it is an inverse and not the original. So that would just be your last step. Just note that it's the inverse. So we're going to come down here and look at number 3. So we'll come back to 1 and 2 a different time here. So first thing it wants us to do is find the inverse of this equation. So we're actually going to do that second and then graph the given function and the inverse that we find for. So we're just going to do the original first. So let's focus on that. Then we'll talk about the inverse. We'll graph all the points, find the domain and range for the original. So we've got x squared minus 1. X is greater than or equal to 0 is just a domain restriction. Because when we go to find the inverse, it's going to end up being an even root radical. So we need to make sure we don't have imaginary values. So that just is important for when we go to graph. That's why I started my table with 0 and nothing smaller than 0. So we're starting at 0, 1, 2, and 3. So all we are doing is taking that function, so it's really y equals x squared minus 1. So all we're doing is taking our values in our table and putting them in for x. So 0 squared minus 1. So 0 squared is 0, minus 1, negative 1. Then 1 squared is 1, minus 1 is 0. 2 squared minus 1, 2 squared is 4, minus 1 is 3. 3 squared minus 1, 3 squared is 9, minus 1 is 8. So we are going to graph these guys on our coordinate plane over here. So negative 1, 0, negative 1. 1, 0. 2, 3. 3, 1, 2, 3, 4, 5, 6, 7, 8. And just like our radical functions, that point you guys plot on the left will be your first point. I could have drew that a little nicer. And that is going to be our original guy. Okay, it might help to label that first point as 0, negative 1. All right, so before we find the inverse, we're going to come back and do the inverse. We're going to do everything for the original function first. So now we're going to look at your domain range and your intercepts. So remembering that domain is x, range is y. So your domain is going to start at the x value of that original point. So your domain is going to start at 0, because that is your x value, and then goes to positive infinity. Your range is the y value of that point and goes up, so -1 to positive infinity. And then since you have it graphed, we're just going to literally look at where the x and y intercepts are. So your x and y intercepts are just where it hits your x and y axis. So your x intercepts that guy right there. So 1, 0. And your y-intercept is that guy right there. So 0, -1. Okay, so now that we've gone through the process of finding everything for the original function, we're going to go now and do the inverse. So we're going to use those steps of algebraically finding the inverse. So we're going to replace that f of x with y first. So instead of having f of x equals x squared minus 1, and we're going to do this guy in a different color, we're going to make it y equals x squared minus 1. So that's step 1. Replace function notation with the y. Then you switch your x and y, so we're going to make it x equals y squared minus 1. And then it's going to differ from time to time just based on what your equations are. But the goal now is to get the y by itself. Like you want an equation for that has y equals. So we're trying to isolate the y. So we've got y squared minus 1, trying to get y by itself. We're going to add the 1 over. So now we will have x plus 1 equals y squared. How do we undo our powers? We will take the roots. So since it's a square power, we will take the square root. That cancels that guy out, leaves us with y. And then the square root of x plus 1 over here. So I'm just going to write it in inverse notation. So we originally had f of x. We're going to write it as f to the -1 of x equals square root x plus 1. So that's our inverse equation that we're going to fill out our table over here. So you could try to figure out what values to plug in, but if it's an inverse, your values just switch, guys. So I'm just going to take these y values that we found from the original. As long as you're confident that that table's correct, you can take those y values, and that's what you can use for your x. So I'm just going to put those guys right here. And then we're going to plug them into our inverse function. So we've got the square root of x plus 1. So the square root of -1 plus 1 is 0. Square root of 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. 3 plus 1 is 4. Square root of 4 is 2. 8 plus 1 is 9. Square root of 9 is 3. So they should just be the mirrored or flipped from your original. So like I said, if you're confident that that table is correct, you really can just switch them for the inverse. But we need to know how to algebraically find that inverse equation. So we're just going to plot these points now. So -1, 0, 0, 1, 3, 2, and 8, 3. And we're going to label that as our inverse, so the little -1. And I'm going to label that first point where it starts, so -1, 0. So when you guys go to fill in tables, some of you guys are just going to know that they're switched. Some of you guys will use the graph. It's going to sort of differ on how you figure out this table. But now that you've got the inverse graphed, where does the domain start? What is that x value where that graph starts, that is negative 1. So your domain for the inverse will be negative 1 to positive infinity, and then the y is 0. So that's where your range will start. So again, they just switched domain and range from the original to the inverse. Okay, and then since you've got your graph right in front of you, x-intercept is negative 1. Y-intercept is positive 1, so 0, 1. So again, really just switch. So some of you will just figure out from the table that they're switched. Some of you will like to graph it and find it that way. But I think the easiest is do all the original function pieces first. So graph the original, find the domain, range, and intercepts of the original, then go back and do the inverses. I think that is the easiest way so that you're not trying to do 2 at once all the time.